In this video, we will learn how to calculate sine theta, cos theta, and tan theta, which are the trigonometric functions. We are going to consider that a triangle is given and we know the sides of the triangle, and we will see how we can calculate the ratios sine theta, cos theta, and tan theta. Let us consider a triangle A, and this triangle A has 45 degrees at R1. So in other words, our theta here is 45 degrees. Now if we have to calculate sine theta for triangle A, so let me put here triangle A. If we're going to calculate sine theta for triangle A, we know that theta is 45 degrees. So we're going to replace theta with 45 degrees and call it sine 45 degrees. So sine 45 degrees we know is equal to opposite side by the hypotenuse. Opposite side over hypotenuse. I'm writing it in short form. And similarly, cos 45 degrees is equal to adjacent side over hypotenuse. So that is equal to adjacent side over hypotenuse. And our tan 45 degrees is equal to opposite side by adjacent side. So opposite side over adjacent side. Okay. Now that we know these ratios, we're going to estimate or evaluate the actual value of each of these trigonometric functions for the triangle A. So in triangle A, sine 45 degrees, which is equal to opposite side by hypotenuse, will be O1 M1, which is the opposite side. So let me put it here, O1 M1 divided by the hypotenuse is M1 R1. M1 R1. Similarly, we can mark all the other two. So cos 45 degrees for triangle A will be adjacent side, which is O1 R1. O1 R1 over hypotenuse, which is M1 R1. M1 R1. And tan 45 degrees will be opposite side by adjacent side. And the opposite side of triangle A is O1 M1. O1 M1 over O1 R1, which is the adjacent side. O1 R1. I hope this is very clear to you now. Okay, so let's move on. Now let's find out the actual values. What is O1 M1? O1 M1 is given as 5. So this is equal to 5. And M1 R1? M1 R1, which is hypotenuse, is given as 5 root 2. So over 5 root 2. We can simplify this mathematically, and we can call this as 1 by root 2. Similarly, let's estimate or evaluate cos 45 degrees for triangle A. So we know we have found out that cos 45 is equal to O1 R1 over M1 R1. So what is O1 R1 in triangle A? O1 R1 in triangle A is 5. So 5 over M1 R1. M1 R1 is 5 root 2. So that is equal to, by simplification, you will get 1 over root 2. Similarly, let's calculate tan 45 degrees for triangle A. So tan 45, we found it to be O1 M1 over O1 R1. So that's equal to O1 M1 is 5 over O1 R1 is 5. That's equal to, by simplification, you get 1. Great. Let's now try and do for triangle B. I'm going to call this as triangle B. So I'm going to give you a few seconds to calculate each by yourself, and then I'm going to do it. Now, can you tell me what is sine 45 for this triangle B? I want you to express in terms of this O1, M1, in terms of the vertex of the triangle. So sine 45 degrees will be equal to, you're right, O2, M2 over M2, R2. Excellent. Now, can you evaluate what is cos 45? Good job. It's O2, R2 over M2, R2. O2, R2 is the adjacent side, and M2, R2 is the hypotenuse. So, adjacent by hypotenuse. O2, R2 over M2, R2. Great. Now, can you find what is tan 45 in triangle B? Yes, it is O2, M2, O2, M2 over O2, R2, O2, R2. Excellent. So now you know how to find the trigonometric ratios. Let's put the actual values now. What is O2, M2? O2, M2 is 1. And M2, R2 is root 2. And let's go to cos 45. Cos 45, O2, R2 is 1. And M2, R2 is root 2. And the last tan 45, O2, M2 is equal to 1. And O2, R2 is equal to 1. And you get this as 1. Now I want you to notice one thing, that even though our triangles are different in size, triangle A is definitely larger in size than triangle B. But you will notice that our trigonometric ratios are the same for both these triangles. Let's say sine 45 degrees for triangle A was 1 by root 2. And sine 45 degrees for triangle B is also 1 by root 2. So they are both equal. Similarly, you will notice that cos 45 degrees is 1 by root 2 for triangle A, and it's the same for triangle B. It's also 1 by root 2. Do not get confused that our sine and cos values are the same. They are the same because this is a triangle. It's an isosceles triangle. So two sides of this triangle are the same. The opposite side and the adjacent side are same. That is why you're getting sine and cos to be equal. So it is not necessary that you always have sine and cos to be equal. We will be doing more trigonometric ratios with different angles. So then you will understand that they're not always the same. Now, our point here is to know that our tan 45 is also the same for triangle A and for triangle B. So, what do we conclude? In conclusion, the sine value of both triangle A and triangle B are equal. The cos value for triangle A and triangle B are equal. And the tan value for triangle A and triangle B are equal. Irrespective of the different dimension, they're equal because the angles are the same. And we have also learned in this video how to actually calculate the ratio if you are given the sides of the triangle.